Okay, so in this video, I'm going to explain how we can understand NuSMV counterexamples and how those counterexamples can be used in testing. Here is our example model of the 2-bit shift register. You can see the states A, state B, and state C and state D. And the property this time we are going to verify on the model is G bit 1, next bit 1. Not this property we just examined in the last video, it was true. So now I just changed a little bit. I change it to next bit 1, and if you see, according to this property, wherever we see bit 1 to be true, then in the very next state we want to see whether bit 1 is true or not. The property say it is true, but we need to see whether it happens in the model or not. So again, bit 1 is true in state B, and bit 1 is true in state D, and it is false on state A and state C. Now the outgoing parts from state B is this one and this one. If you follow along these paths and see the next states, for B next state D, here you see that bit 1 is true. So in this case, the property holds. But if we follow the path from state B to state C using the zero transition, here you see that bit 1 is false. So it means we found one path along which the property does not hold. In the same way, if I follow the outgoing path from state D back to state D, then bit 1 is true. It means on this state, if it becomes, when it becomes the next state of itself following the transition which comes back to it, then again bit 1 is true. Now we have another path that goes from state D to state C. So we have bit 1 true in state D, and the next state for D is C if we follow the zero transition. Here again you see that bit 1 is not true. Sorry. So we found two paths along which this property does not hold. I am marking those paths with this red ink. You can see that if you follow this path, then the property does not hold. We found bit 1 to be true in this state, but bit 1 is not true in the next state if you follow along this path. In the same way, if we sorry, if we follow this path, then bit 1 is true actually here in state D, but in the very next state bit 1 is not true. So the property is not true for this model on at least two parts. So now we will execute this property on in the new NuSMV model checker. We have already coded up the model. I will change the property and we'll see what NuSMV shows us. So in fact, it can run in many in different modes. So we are going to use a non-interactive mode, and in that case it is not going to show us all the counterexamples. It will just show us one counterexample, and we will see which counterexample that one is. So here you see the property which I wrote in the last video. I have the model coded up here. Now I just change this property to let's comment this one first. So we use a double dash to comment in NuSMV. So I write a new property G bit 1 and implies that next bit 1. So I want to test whether whenever bit 1 is true, in the very next state bit 1 is true or not. So I save this, and now I run this on this example model, so which is the 2-bit shift register model. So here you can see that it is in this directory bit shift complete.smv, and I am working on this. So let's run NuSMV on this. So there you see it says this specification is false, and it has given us a trace or an execution sequence which is like this one. So how do we read this? So these numbers, state 1.1, state 1.2, state 1.3, this one, and so on, state 1.4 and so on. So these are the numbering NuSMV actually assigned itself. This has nothing to do with our states, which we name like A, B, C and D. So it actually unfolds those states starting from the initial state, and then it finds out the path on which the property is breaking or is being violated on the model. So what happens is that this basically is the initial state. So this is the state where we had both the bits false, and we named that state A, and it is saying us that from that state if you read input true, that is input equal to 1, then you get to another state which it marks as state 1.2, and here it's showing that in that state bit 1 is true, so it's not showing the value of bit 2. So bit 2 will have the same value which it had in the previous state, that is bit 2 will be false. So bit 1 has now become true and bit 2 is false. So it is the state which we have labeled B in our diagram. So now if we read a false or a 0 from that state, then we go to state where bit 1 is false and bit 2 is true. So now the values of bit 1 and bit 2 have changed from the previous state. So bit 1 was true in the previous state B, now it has become false, and bit 2 was false in the previous state B, it has become true. And if you remember, this is exactly the path which I showed you on the slide, that if you start from the initial state, go to state B and then go to state C, then the property gets violated. And it then again says, if you read another 1 from here, you go back to state B, and then again both bits change and we end up in this state B, and then it says loop starts. So in non-interactive mode, NuSMV is going to show you counterexamples which have loops. It basically is because of the algorithm it's implementing on the back end. So however, we are interested in finding out this state sequence or this input sequence that results in the property being violated on the model, or the property not holding on the model. So we just found out that if we follow this sequence of states till this point, so that property actually, we know that bit 1 was true in some state, for example here it was true, but in the next state it has become false. So this is precisely the reason why this property is not holding on the model. So I just explained how you can actually find out what goes wrong and how the property is being violated or is not holding on the model.